Thank you, Mr. Medi. Thank you, Fred. Appreciate it. Rusty after a week off. Okay, so let's figure out what the difference between these contexts is, and then we can figure out where things went wrong. So this is Warmanon. I'm assuming Warmanon is the same as EU Games. Or it would have been faster to just paste to cat. And we'll see here what the difference ends up being. Maybe not any faster. Oh, this. So there is a change the entity offset, and then yeah, the two functions that we had commented out below. Let's look at that again. All right, so here's this unknown bit. What's interesting about this is we do have an entity extension that has that in place, which means our entity extension is going to be larger and overflow this, and that may ultimately be the issue. So let's copy that implementation back and oops. Looking too fast. All right, and I do wonder if possibly this was reverted. Okay, so that works. I'm gonna have to go look at the entity header file again and see if that change is still there. I know a couple weeks ago that was added, and it's possible that it was reverted. So thank you, eGames, for finishing that off. I will leave that as I check in the other stubs for this. I'll leave that if you're watching and want to contribute that yourself, and if it hasn't been done in a couple weeks or as we finish up the rest of this, I'll make sure you get credit for that change. So I do want to look at the entity header, and sorry, that's in game. The entity struct. So we do still have B8 here. Yeah, I wonder if my context was just screwed up for some other reason. Oh well. not terribly important. Thank you everybody for showing back up after a week off. I appreciate it. Didn't spend any time doing anything related to Soten. So pretty much exactly where I was when I left. Let's look for something new, and we'll see if we can find something. So I did spend a little time this morning looking at the make config utility that we have, which wasn't set up to be able to create configs easily for familiars. And so I submitted a PR for that this morning, which should map any duplicate functions or other things like that. So we have a few symbols in here now that that should have been deduped correctly. So we won't look at those. We can just keep going on these next ones. So we'll go to the next function and see where we are there. What I want to do is find that in find its assembly. And copy it, and we will start a new scratch. I did spend some time looking at some of the familiar stuff. There's details about familiars that I wasn't completely sure of. I had no idea of the fairy singing this song when you sit down. That's kind of funny. A whole bunch of things that you come across. So this one is a very short function. Wasn't one that matched on the dupes report though. And it looks like a pretty straightforward function. I don't think we'll have any problems with this one. We're getting a 90% match already, so we should be able to get this done pretty quickly. So this was imported. If you haven't watched the channel before and aren't sure what's going on, I took the assembly from a function that has been identified by Splat. Took the assembly language version of that function, which can be derived from machine code, and uploaded it to decomp.me, where we're going to attempt to decompile this function. And that just means creating the C that will produce the same assembly. Do a few things to set up the workspace, and then look at the differences that we have here versus what is in our target assembly. So the first thing is loading this immediate 11 value is happening in a different order than we expect. So it's possible that this is coming from a variable rather than something that is getting set directly here. Well, I do want to see what the difference is here. So this is going to be our entity ID, and we'll just call it that. This may not be a separate variable. This may just be getting set in line. So let's try this. Let's say if arg1 is not equal to 0, then we're going to set entity ID to df. Otherwise, it's going to get set to DE. And that should give us hopefully something equivalent. And that might be enough to fix the ordering of that assignment above. Not quite. These are often out of order, and that is a well-known issue. Usually things like position are next to each other. We can call arg0, we'll call it self, and treat this as if it's a method. All right, so it looks like we have some ordering here that I always forget. That was our original. Try priority facing left and then flags. Is that going to give us the right order? Yes, that gives us the right order. So the only thing remaining then is this, and actually this ordering here. This may or may not be related to needing struct access for G API. It's not. So let's try pulling that out into a variable and see if that does anything for us. Get free entity. Let's look at the signature for that. Function I'm familiar with. Biz Murphy recently started work on getting DRA ported to, or the PSP version imported for DRA, which should get a lot of that code closer to the PSP version as well. And we're looking for get free. All right, so we're looking for just start and end offsets here. No, our let's try one more thing. So, sorry. So I was putting those in variables and seeing if that if I could get the order changed based on those variables, but it does not look like it. I'll back that out. I'm going to try this. I don't know if this is going to work, but let's check to see if the entity ID couldn't be created. We can just return it doesn't make a difference though. So sometimes even what should be a simple thing is not. I'm going to look to see if this has other analogs in other servants, and if not, we can pull the PSP version. I think I still have all that extracted, or can extract it, and then we'll see if that version gives us any hints. So it's not being used there. We have a few cases in stages. Those look like they're all taking these values directly. Let's get the args as well and see if there's anything about the args that may tell us something. It's possible that these aren't the types they say, but changing those doesn't make a difference. So this one is arg2 is params. And we don't know what arg1 is yet, except for a flag indicating whether it's one entity or another. I'm going to flip those just to keep these in order. But it doesn't help our argument at all. All right, I'm going to, pull the PSP version. Oh, I'm not signed in. That's okay. And we'll take a look at that. Let me find size of this original one. So I found this, and I think this is the same. Yeah, so we have our 11 and 2F. Oh, drat, I created a PlayStation scratch, which will not help. Let's see if that works like this. All right, I think that seems fine. Okay, so a few things different. It does look like there is some additional stack space that's being used that we don't have. It's possible that it's related to this entity ID. I'm going to flip this comparison around. I don't know that it'll make a difference. It does look like this might be coming in as a sine 32. Which is causing the mask. And that actually might be enough to get us a match on the PlayStation. Yep, that looks like it was it. So we just had the type wrong, and the type was inferred by M2C when it was decompiling. Because this value was being assigned directly to an unsigned 16, M2C inferred that the parameter was an unsigned 16. But in this case, that wasn't true, and accounting for that, the parameters is a little strange because it would still use 32 bits for this argument register. So I'm not sure why the assembly changed as much as it did by switching that from a 16-bit to a 32-bit value. I'm guessing if this is any type of 16, it would result in the same issue. Likewise, any type of unsigned. So we don't need to know exactly why, but that does fix that issue. So the PSP side, on the other hand, though, is still not right. So let's try to get the PSP side a little closer to right. And when that was being decompiled, it did have the original structure that the PlayStation version had. So I'm going to make the assumption that this is actually using the... so we'd say S32 in this project. My guess is that they were saying int originally, just because it's easy and more straightforward to do. And so I switched this to not assigning a separate variable, but assigning the field directly. And it looks like the PSP version is saying that that may not be the case. It may be a separate variable. And I like to capitalize my D and ID. All right, so it looks like these are backwards. And these will end up being enum names rather than hard-coded values. And so this while I like the order in the other direction, it doesn't necessarily need to be that way. So we're only missing one more thing, which is this register on line 6. So the original version is using V0, which may indicate that we're returning this. So let's try that and see. Yeah, that changes quite a bit more because we need to maintain that V0 register. All right, so why might we be using... let's first try this. Why might we be using S0 as opposed to V0? when both are open to us. That's not clear to me. Our move here from V0 to S0 is taking the return value from this function and putting it in the S0 register. At this point, at this next instruction, this branch instruction, there's either one of those registers could be used because either of them now have the same address in them. And so which one it uses is really just up to the compiler at that point. There's another instruction in the branch delay slot, but it's a no-op, so it doesn't affect which register is being used. So I'm not really sure why. And then what's somewhat interesting here is that that not as interesting as I originally thought. We're using that entity then. One thing I may want to try is replacing that entity with self and see if we just overwrite that instead of using a separate variable, if that makes a difference. I'm not convinced that it is going to make a difference, but we can try it and see. I'm not worried about matching. That makes things much worse. I'm not worried about matching PSP at the moment. Just kind of curious why the compiler did try to use that instead. Let's do one more thing and see if we put that in line, if that makes a difference. And that works. Okay. So inlining it gives us the result we want, and that should work on the PlayStation side as well. But it doesn't. And the difference is here. So let's try to flip this and see if that is going to give us a match here. Yeah, so there's something else going on with how these entities are being assigned. I can go back now that we have that other part matching and put this back in place on the PSP side as well and see if that still works. Yeah, so what the PSP side is telling us and is going to be hard to get around is that that assignment is only happening once. So these are a little bit different. I'm not completely sure why. I am going to try to get them as close to the same as possible. So this is matching in largely the same structure as the PSP version. Oh, sorry about the stream. I did over the weekend experience symmetric upload. Boy, oh boy. Being able to upload at several hundred megs a second is pretty sweet. I'm sure most of you know that though. So this is as close as I think. I care about getting the PS1 version at the moment. So we should be able to get this in place here. And all right, so we're missing a few things. We don't have a header yet for the sword familiar. So let's create that, and we're going to include game.h. And I think that's all we need for now. And that worked. All right, so that was a pretty simple one. Let's see if we can find anything a little more complicated. I am going to look at... so OneNut McGee just merged a bunch of stuff for the Demon Familiar, and I wanted to see how far down the similar code is. So here we have the servant update animation, destroy entity, and things like that. We probably can go all the way down to servant 0 and duplicate those includes. Doesn't look like we have a lot of the RO data in Sword Familiar. I'm not sure if this will work without any other changes, but I'm willing to try it. So there are several variables and macros we need to define beforehand, and unfortunately the easiest way to do that is to go through each of these functions and find where those symbols are. And that can be a little boring. So I'm going to go back up and let's just find what the next... any of our unnamed functions are fair game, except for maybe check entity valid. We don't have that over here. There may be some, I guess, that are duplicated. But let's look at the top ones, and we'll see if there's anything up there that's a little bigger that would be interesting to work on. I'm not going to start at the biggest. All of these are pretty small, though. We'll start somewhere in the middle. Actually, I'm going to not sort these. And I'm just going to work from the top down. Now they're not in the order that I was hoping that they'd be in, but that's okay. You know, we can go with them. So we're going to look at 5.9c. Oh, and that happens to be the next one. Great. Now I'm going to, off screen, I'm going to sign in. There we go. All right, so something a little more complicated, but it doesn't look terrible. We do have some types that once we identify what type they are, this should be a bit easier. Some fairly simple loops, it looks like. So we do need to start going through and figuring out what are the things here that we're looking at. So I'm going to make the assumption that we're taking a entity in as our first argument. And one hint here is that at offset 64, we're looking for a primitive ID. So to confirm that suspicion, we can go and look at the entity structure and look at offset 64, which is a primitive index. So that was a good guess. We don't know what the other two arguments are, or if there actually even are additional arguments. Sometimes those are just registers that are being used that M2C mistakes as arguments. I will do a new decomp to see if this was able to tell us anything new. Not much yet. So we're going to have to start looking at what this data is and go through each of these one by one and start figuring out data types for these. We can do that one of two ways. We can look at how it's being used. And we see here, for example, that we're using offsets of 8. And it's something in the scratch space. These may all be related and similar, but we can look at the data there and see if we can figure out what those are. So these look like they're just 16-bit values. It is possible that they're being used in sets of 4 to give us that offset of 8. I do want to see. We have these other offsets immediately below, but my guess is that those are just fields of that same structure. So what I'm going to do is I am just going to give them a size of 16, signed 16 value, but I do think that they are going to be treated as an array or a struct. We won't be able to tell that quite yet, though. And let's look at this next one. These look very similar. And then finally these last ones. These are in SPSS, so this is uninitialized. These will all just be zeros. That makes it much more difficult to determine what their size is, whether they're part of a struct or not. All we know is that they appear to be 32-bit values. Let's look at how they're being used in... more likely than not, though, that this is some... some struct. We can look at this temp A0. No, maybe not. It may just be 32-bit values. So it is an array of 32-bit values, but it doesn't look like anything other than that. So that's actually easier than I expected. Don't know if they're signed or unsigned yet. All right, so I think we'll start with this and try to get the loops figured out, get some of these variables renamed. So far, A3 is going to be a primitive, and so we'll just call that prim. And the only thing we have to watch out for is whether or not there's a second use of RA3, but it doesn't look like it. So it looks like I can just replace all of those. We do have some compilation errors still. So this var1 we don't know what it is yet. It does look like this is somewhat odd. We're taking it from one of these two addresses, but then taking an offset into that address and then using a field within that. So the var1, we need to see what our stride is. Looks like the stride is 4. So these are pairs of it looks like UV values, which is our coordinates in the texture space. The way that this math is being done, or the offsets are being calculated, is a little funny and very much oh, thank you. The way that these offsets are being calculated is very much like a optimizing compiler way to do things rather than what this is going to shake out to be. So I think what we need, it looks like we're looking at pairs of unsigned bytes, and then we're kind of incrementing that and then taking the next set of values from those pairs. So I'm going to try to here, what we want is basically we're just taking the second index at that same offset. So at 89, the same thing is happening. This will work out better when we figure it out. just keeping the values there for so I can remember what they are when we get back to it. All right, so var a1, this is going to be texture coordinates, and we can call that UV pairs. Not terribly important what we name it, but just as long as we know what it is we're looking at. And so then when we're pulling values from that, I think it makes the most sense to subscript these values, prime 0. Actually, these look like, it looks like it's just taking the lower part of a 16-bit value. Let me finish these replacements. And I will go find this. So this is storing the byte. Yeah, the way that these are... Okay, they are being loaded as bytes. The offsets are a little funny, though. Let's clean the rest of this up first, and then we'll get back to that. Var A2. This looks like the I. Or index variable. And I think we can get away with making this a normal for loop. And this is kind of a funny for loop afterwards, but basically we're just continuing on with that same index. It's not being reset. And the draw mode's getting updated. I want to see where we are versus what's changed. The variables here are setting various things in the scratch space, or the scratch pad. So we'll have to come back and look at that. But let's do the same thing down here as well. And several of these pointers that we're going to get rid of those are being maintained along the way because the compiler is using those additional registers to keep pointers that are all incrementing along with each other close together at their respective indexes. All right. And what the difference between these two are... so this var t1, I don't think is going to be anything other than just indexing into this array. And the variable is getting created by the compiler. And it's maybe similar here as well. We'll have to see with temp A0. Yeah. So these are going to be similar where they're all just indexed I of these other addresses as well. And so that means we need to figure out or correct the type here. No, that type is correct. Subscript values neither in the array. Is an array. And so the same thing is going to be true down here as well. I think all of this would probably be easier to figure out on the PSP version. Most of this would be less convoluted. var t0. This tells me that whatever this is a size of 8. And I think we looked at this already. Oops. So it looks like these are for four 16-bit values together. They are being cast as a 32-bit value, but I don't think that's the case. Oh, I'm sorry. I read that incorrectly. The index is 32 bits, but we should be incrementing this by 4 each time, as well as this. And I don't think that's gonna... no. Or not. Okay, so this may be two 32-bit values. I do think that these are going to be indexes, though, as well, as opposed to something else. So let's change that to an index, and yeah. So this appears to be quads from the same offset. So we've seen that before, and let me see if we have a struct that is going to be a... Yeah, let's assume that these are rectangles. So this turns into an array of recs, and that gives us hints then as to what else we're looking at as well. So this will be I, and then each of these will be the offset of whatever the field is that it's looking at. It is a little odd that the height isn't being used here, so it's possible that these are rect structs specifically, but we can use that structure for now and then change it as appropriate. And then we're adding it to this offset within the, basically using it as an index into the scratch pad. And so we may have to look at that as well and see why we might be doing that. And then I think this var t0 goes away. We did lose a bunch of our match here, and let's see if that's justified or not. A possible issue with this is because the symbols are going to be shifting. The compiler knows these symbols were pulled out by Splat and aren't necessarily real symbols. They're just addresses that are baked into the compiled version. And so those will be different now that we've changed it to field offsets. I'm not terribly concerned, though. The shift here is possibly more concerning. So let's reorder some of this. So this looks like it's going to be the same as UV pairs. We're going to keep going down and incrementing that UV pairs pointer. Let me look at this temp A0. I think we can get rid of that now as well. So let's try to figure that out. There's two possible ways to do this. One is to take our two values and then increment. It does look like the stride here though is 4 bytes. But currently we have a pointer to just single byte values, which is that's a little strange. I'm going to play along though and see if we can get something that looks consistent. And okay, so now we have something a little different. We're pulling the same value for V2 and V3. When these are backwards like this, usually that means the assignment is together on one line. So that's looking pretty close. This odd load immediate is coming from these scratch pad offsets. There are macros for these, so I'm going to look for those macros. All right, so that looks like something like this. That one actually isn't closer. I'm not sure why these are being loaded like this, but yeah, having this the constant for the scratch pad out of order is a little strange. It may be caused by something else. I'm not sure. These are getting incremented by 2 bytes like I thought, which suggests that these are just offset 0 and 1, which is what I would expect. Yeah, and there's something else going on here that's not quite right, but I'm not terribly concerned about it. The structure looks okay, and I'm happy with what some of these offsets are for the time being. And then as we look at the PSP version, we may be able to get a better sense of what's going on here. The second half of this is going to be largely the same. The only difference in the logic is where we're getting these values from. So instead of the pairs coming from one pair of addresses, they're coming from a different pair. And that should probably work out to be just about the same. The same with most of this as well. There are several variables we can get rid of. Not everything yet. But as we start moving this into... I will fix these. As these get closer... I do expect that more of this will start converging onto a match. We can clean this up a little bit as well. There's a bunch of these that will end up falling into the same pattern as above. And so even if we don't put it in exactly the same structure now, we can get rid of a bunch of these temporary references without really affecting any of the match that we have so far. Yeah, it is odd that so many of these are +2. I'll just duplicate this. And then there's the business down here as well. We're using a different... Using a different starting point. So I think this is going to be the general structure, and then there's some details we're going to have to figure out along the way. Let me clean up these variables, and I think that's where we're going to end today. And I will pull the PSP version for tomorrow, and that'll give us a little additional insight into what else might be going on here, maybe what some of the data types are. I probably will spend a little time looking at the data as well of the Sword Familiar tonight, and see if there is anything else I can learn about it before we continue on tomorrow. So a little closer, but not obviously some ways to go. And I think that seems okay to me. All right, so we'll end it here for today. I appreciate everybody joining again. I'll be back to the regular schedule this week, which is fun for me. You can go to soten.z.dev to learn more about the Castlevania Symphony of the Night decompilation project. And you'll find a link to GitHub, and you'll find a link to Discord. Join us. There's been a lot of people who have come through Twitch and through YouTube, and I'm really appreciative of all of the great contributions that have been made to this project through those channels. I'm just another contributor working on the project the same as anybody else. And welcome you to join if it's something that interests you. If you just like Castlevania, you're free to join for that as well. Anyway, that's all I have for you today, and I will be back tomorrow. Adios.